So really, all of the things that you're seeing on this screen right now, these are really just like a set of directions. Remember, a lot of times people say like, oh, the mathematician is actually kind of a lazy person. We're always writing all these notations just because we're too lazy to write out what we want to do in words. Okay, so rather than describe it in words and have all these paragraphs and sentences about what we're doing, let's just make up a notation for that. So the important thing to remember about each of these notations when you see them is they are like function notations. So that x that's in the parentheses in the back, that is not like times x, right? That's just part of the x that's in function notation. Addition can be written like this, where it tells you like which two functions to add, f plus g, but sometimes we also see it like this, like f of x plus g of x. Like those two things mean the same thing. And we could do that with everyone. F of x minus g of x. F of x times g of x. F of x divided by g of x. Okay? And then we also, I think, have seen this notation in chapter 4 for decompositions. I'll move that up. So there is a second notation that you'll sometimes see in different textbooks or classes or teachers. They'll use either one of these. It looks like an open circle. Okay, so it looks like it says fog, but it's just f of g of x again. So it's a composition. Remember, the composition is substitute a function in for x. So you're not doing multiplication. It's not like f times g. You're taking g and you're replacing the x with that function. Okay, so it's a substitution, not really a operation. I'm going to do a few different examples, but I'm going to put up on the screen there will be 4 different functions. So I have them named differently, and we're just going to keep reusing these 4 functions. So if you write those 4 functions at the top of your notes, you'll only have to write them one time, and we'll just do different operations with them. Okay, so these are the 3, 4 functions that I have. I'll move them so you can see them. This one, I can grab it. There it is. There we go. Okay, so I've got f of x equals 2x minus 3. I've got h of x equals x squared plus 4. So I've got one linear and one quadratic. I've got g of x equals 3x to the 1/2. And j of x equals 9x to the 1/3. So that's a square root and a cube root, right? Rational exponent. Okay, so we'll do a few examples, like I said, with these over and over again. So if you write these 4 down once at the top of your notes, then we're just going to do different operations with them. Okay, so let's see. I think, yeah, I got a whole bunch. Okay, so we're going to start with f minus h of x. F minus h of x. So it's saying take f of x and subtract h of x. So write down what you think you're going to be doing. F of x minus h of x. If you can't do any kind of like simplifying, combining like terms, multiplication, those types of things, you should do it. F of x is 2x minus 3. and I'm subtracting h of x, which is x squared plus 4. Notice I like to protect my functions with parentheses just in case I need them. If I don't need them, then no big deal. I can ignore them. In subtraction, parentheses are important for this back one, h of x, because I want to subtract the x squared and I also want to subtract the 4. So I always distribute my negative to those two terms. So this is really 2x minus 3 and then minus x squared minus 4. So if I clean that all up, I got negative x squared plus 2x minus, 7? That's a new function made from the difference of two other functions. Now, it does say to state your domain. So, f of x was linear. You can put anything you want into linear, so that has a domain of all real numbers. H of x was quadratic, and those are the parabolas that open up or down, so they have domains of all real numbers. And then my answer is just another quadratic, so my domain is all real numbers. There's nothing that I can't square. Like I can square negatives, and I can square positives, and I can square 0, and I can square fractions, and square everything. So there's no restrictions to my domain. Okay, you're looking for things like rules in math that you can't do to something, so then that's going to restrict your domain. Let's try f of g of x. F of g of x. Actually, let me see if I can. Move that up. F of g of x. Okay, so for f of g of x, that means I'm going to put g, which is 3x to the 1/2, in for x in f. So I'm making that substitution. So that'll be 2 times 3x to the 1/2 minus 3. So to me, it really is 2x minus 3. 2x minus 3, but x is a new function, right? We put g of x in for the x. So we've replaced it. Simplifying it, I guess I could do 2 times 3, couldn't I? Get 6x to the 1/2. 6x to the 1/2 minus 3. Can't really do any of that other subtraction, so this is my final answer. Okay, now think about domains. You know, f of x was linear, which would have been all real numbers, 2x minus 3. Okay, put anything I want into that. G of x, 3x to the 1/2, what kind of function is that? That's the square root. Doesn't this say 3 times the square root of x? Really? You put anything you want into a square root? No, you can't do square roots of negative numbers, right? We had that conversation yesterday with the inequalities. So our domain for this one is everything greater than or equal to 0. Like 0 is the last number I can take the square root of. When I look at my composition, I'm really going to have the same thing, right? It's just the square root of x. And I can't do anything less than the square root of 0. So I'm going to say my domain is x is greater than or equal to 0. All right, will you try the bottom two? They are h of x divided by f of x and f of x divided by h of x. Not too terrible. See if you can set them up. I'm going to move this up because you already have the h of x and the f of x written down, right? So that we can see more. Does that look like your setup? Put one function on top, one function on bottom. That's as good as that gets. If you started to get a little bit cancel happy, like crossing off x's or other things like that, because these are terms, like x squared is a term that's being added with 4, and 2x is a term that's being like added with -3. They're not factors, so you can't like cross off an x. Okay, so don't get too cancel happy on those. That's as good as it is. What about domains? Have a chat with your group. Is there anything troublesome about domains for f divided by h or h divided by v? H divided by f. Have a little conversation. Do you see anything being troublesome, like a rule in math you can't do? With division. Any rules for division you know? Yeah? I mean, if you're trying to solve and there's a fraction, you might multiply by the reciprocal, but h divided by f, we don't have to do any kind of reciprocal for that. So you see you have x's in the numerator and x's in the denominator, right? Okay. So we just want to know, like when we're talking about domain, are there any x's that won't give us answers? Like up in the composition from before, because we had a square root of x, we weren't going to be able to square root negative numbers. So are there any numbers that you can't use in division? Can't divide. We're going to avoid the imaginaries, but I don't think we'll have any imaginary answers with the x squared plus 4 and the 2x minus 3.